Hello, everyone. My name is Mike Erlihson, and I'm a principal data scientist at Salt Security. In this talk, we are going to discuss machine learning for API security, promises, and main challenges. Okay, so about me, my name is Mike, and I'm leading the data science at Salt Security, and we are developing advanced machine learning and not just machine learning techniques to battle sophisticated API attacks. Okay, agenda for today's talk, short intro about what is API security and about several types of API attack. When we discuss shortly the evolution of API security and API attacks in the last 10 years, then we'll get to machine learning promises, the challenges, and if time allows, I'll talk about our SALT approach for API security. Okay, let's start talking about API. Gartner predicted that in 2017, that API attacks will be the most frequent attack vector for data breaches, and now, and now they say that they are too conservative and underestimated the rise of API attacks. In this slide, you can see couple of most significant data breaches which happened due to API attacks. Okay, so you probably think, oh, it is so easy. We have API gateway, we have a WAF, we are doing a pen test regularly, so it should be protected. Okay, so we think that the situation is like this. But unfortunately, the situation is quite not good. So this is a quite big misconception. And every one of these companies, which you see in my first slide, had all those tools, WAF and pen testing and gateway. They have one, but they still were attacked and the data was breached. So the situation, is like this one. Okay, so now let us discuss what can be changed since 2010 in API security. So what we had, let's start from what we had in 2010, 12 years ago. We have APIs had only basic capabilities. They were changing very rarely, and the API attacks were quite rare, but were basic, mostly code injection like SQL injection and XXS cross-site scripting, and they were generic. So the generic, it means that they were not tailored to the business logic of the application. But now, and the protection we had then were rule-based, WAF and pen testing, and 12 years ago, it worked just fine, and we don't have too many API attacks. Okay, but now the situation changed. In the last several years, the API landscape has changed very significantly. So we have much more APIs, internal and external APIs, and we have a lot of exposed data. It can be manual, it can be not, and there are also many blind spots which even the API developers are not aware of sometimes. So the tools that we had in 2010, the rule-based and the WAFs and the pen testings, are just not good enough in 2022. Okay, so and what are the reasons of the failure of these good old tools for API security? The reasons is the first reason that we have a diverse and dynamic API structure, which is based on a business logic, and we have diverse temporal patterns of API usage. We have different patterns for e-commerce companies, financial institutions, and web application APIs, and many other types. And the very significant problem which arose in the last year, which is new attacks arising all the time. All the time we have the so-called zero-day attacks and new attacks. So the attacks are very frequent, they are very diverse, and new attacks arise all the time. Okay, here I want to bring a couple of examples of API attacks. This example is the broken object level authorization. Here, the backend logic of the application queries the database, the user ID and the query parameter. And then it is verifying the authorization with the user ID and the cookie. Under regular condition, these two values are matching, but attacker could just modify the user ID value and the query parameter in order to access an unauthorized data. And here, which is what you see in this attack, which is called the BOLA attack. Another attack is a mass assignment attack, which attacker is trying to update and to override properties of sensitive objects the developers never intended to expose. And for example, an attacker can escalate his role and bypass this one, and then attacker would get privilege of the admin and perform actions with the application as an administrator, and it is it can be a very significant data breach. Okay, and all good code injection attacks are still with us. They are much more frequent than 12 years ago. So we have many types of attacks. I just showed you three types of attacks. We have much more types of attacks, dozen types of attacks. And the problem is that I already mentioned that new attacks are rising all the time. Okay, so there are many API attacks type. So how we can protect our APIs from all these API attacks? Okay, so what we need, actually what we need is a continuous and automatic discovery of the structure of API and API spec generation via data analysis. So we need to track changes in API structure. We need to also track response and request headers and the body and query parameters. We need to identify it and characterize it, and this way it has to be done continuously. So in addition, we need to continuously we need to detect and update the temporal usage patterns, because they also change from time to time. And one of the things that we have to do, have automatic and continuous malicious user detection based on this API structure we discovered in the first bullet. Okay, so role-based techniques are actually not good enough. So which other approaches we can use to detect a malicious API usage? So now, as you know, machine learning, we can leverage machine learning techniques to detect these anomalies, these malicious API usage. But and now we can use machine learning techniques for API structure discovery automation and also for proactive detection of malicious activities. So at the first stage, we want to discover the structure of NPI and track and temporal changes in this structure. And the second stage, we can detect malicious activity based on the discovered API structure. So we have a couple of advantages. We can learn API spec with machine learning techniques. For example, we can use neural nets from the NLP domain to learn API structure, to learn its fields, to learn its values. And then we can leverage this learned spec to detect violation by using anomaly detection techniques. And then we can use machine learning models to distinguish between anomalous malicious and non-malicious users, because not every anomaly is malicious, apparently. Okay, and this one gives us an ability to detect new zero attacks in real time. Okay, But these advantages apparently come with some challenges. And what are these challenges? Which the first challenge is that we have a data which is very high dimensional, highly nested JSON and HTML, and the structure is dynamic. We have interdependent fields. We have dynamic fields. Fields can appear or not appear. We have dependencies between API request and response fields. For example, there are fields that appears only together, dynamic field names. And the very difficult problem is that the APIs, different APIs, have very dissimilar structure and have different behavior. You can't expect the same behavior from the transportation API like Get or Uber and some e-commerce API as AliExpress, for example. Okay. The one more challenge is that the attacker strategy is changing constantly. So we don't have a prior knowledge about the attacks. We have an old attacks, but we should have an ability to detect new attacks as well. And the one very significant challenge is that you don't have a good tag dataset because our data is constantly changing. Having such dataset is not feasible. We have some datasets, for example, for code injections, but these datasets are very limited and we can't leverage it to build a really good only ML-based solution. Okay. An example of this challenge is DDoS attack detection. For example, for e-commerce API, higher traffic on weekends and spike during sales due to some discounts, it is similar to DDoS attack, but it is not DDoS attack. For transportation API, high traffic after football match or some demonstration, it looks similar to DDoS attack, but it is not. For financial API, for example, for banks, financial institution, here most traffic spikes are suspicious and have a higher chance for being DDoS. For example, the same spike in the traffic can be DDoS and can be not DDoS. It depends on the API. Okay, as you can see, classic supervised machine learning schemes can't deal with all these requirements simultaneously. So they need something different. They need different techniques. Okay, which technique, and then we can, what types of machine learning techniques are capable of addressing all these challenges simultaneously? We can use, for example, unsupervised or self-supervised machine learning techniques and online or dynamic anomaly detection methods. Okay. Why anomaly detection is good for API security? It will enable a continuous protection of API. It will detect an anomalous behavior or malicious data trends. It will detect and block API attacks and abnormal behavior patterns under multiple environments and circumstances. And all these online or dynamic anomaly detection techniques will be capable to detect new zero-day attacks. Okay, but it is easy to say, but it is not so easy to do. The anomaly detection for API security have some challenges. For example, learning of dynamic API patterns is complicated. As I already mentioned, API requests and response in many cases include inner dependencies, dependent fields. API structure can depend on time. For example, the same API can look differently at some hours of a day. The one very interesting challenge is not every anomaly activity is malicious. For example, if a user puts a telephone instead of social security number, it is anomaly, but in most cases, it is not an attack. And one very interesting challenge is that the false detection price can be very high. So if your machine learning model is not good enough, it is generate many false alarm attack, it is very bad because you just don't want to false alarm CEO of large bank because your model just false alarming about not existing attacks. Okay, so as I already said, different APIs have very different structures and really different temporal patterns, the temporal usage patterns. So perhaps we can train our model separately for every API. It can make things much easier. But for example, in our clients have at least 3 APIs. Each one is totally different structure, so we need a model per every API. For 30 clients, we have 90 models to maintain, to retrain, to monitor, and we have much more than 30 clients. As you can understand, it is not feasible. So they need one model for all APIs. Okay, so it means we can't have a machine learning model for every API. So they need somehow to use API representation as a feature to our anomaly detection model. But building this representation is a very untrivial task. Okay, this API representation, an API is characterized by different behavior driven by its business logic. The data is heterogeneous and non-stationary compared to many machine learning tasks, and also they need somehow to provide an API representation reflecting the most essential characteristics in API. And the API model and API has a structure of API. It has responses, it has requests, it has temporal usage. So it is easy to say, but not so easy to do. So what and API representation, when we build the API representation, we want to use some properties of the API. For example, company business segment is a feature to the API representation, and geographical location and company size, and many other API properties are actually input features to this representation. But building this representation is very untrivial due to the heterogeneous data, because you have data which is really heterogeneous. Okay, and now as we build API representation, we want similar APIs to have close representation. But the problem is that even defining distances between API representations, between APIs, it is not so simple. What is similar API? What are the similar API? There are APIs which are similar in some feature, but very dissimilar in other feature. It is very, very untrivial task. Okay, and let me conclude on our SALT 4-stage API detection approach. Okay, the stage 1, the learned API. So we learned API request and response structure and temporal usage patterns. It is quite complicated because we need to learn dynamic fields. We have dependencies between fields, and we have dependencies between response and request structures, and fields which may have multiple types. And learning API usage patterns are also not so simple. So it is a quite complicated mechanism. Several machine learning and not machine learning algorithms are involved to do it. The second stage is to detect anomalous patterns. So as I already mentioned, different API have different anomalies, which is based on the business logic of an API. So the anomalies for different APIs look differently. So it is not so simple to detect them. And in addition, there are different anomalies that have different anomalies have different severity. So there are more dangerous anomalies and there are less dangerous anomalies. And the quantification of such severity is also quite challenging task. Okay, next we build an entities from these detected anomalies. So we have many anomalies. So now we need to cluster them to some entities. So there are a couple of things which we can use. We can use basic stuff like API address and cookies IDs and email and phone. The problem here is that the attacks can come from totally different sources, and they can be erroneously attributed to the same entity. There are more advanced approaches like clustering, and we can use in properties of anomaly features and API structure. And the thing that is there is one more thing that is really complicated to detect is long attacks, which is made of series of hard to detect weak anomalies. You can hardly attribute it to the same entity, and it is really complicated to detect such attacks. Okay, and the last stage is to identify malicious entities. There are some entities which are doing some anomalies, but they are not malicious. You just confused and put your social security number instead of your phone. There's an anomaly, yes, but it is not malicious. And the last stage of our detection is identification of malicious entities. And here are a couple of approaches: supervised approaches and semi-supervised, and clustering approaches used as well. And this concludes my presentation. Thank you very much.